Thank you, Travis, and thank you for all of those in attendance. Both Chinzi and I are excited to present to you the masterclass and our subgroup, which is on holistic digital twin architectures. I'm Michael Carl, joined by Chinzi Chu, and we lead this architecture group to really set a foundation for the industry, a roadmap for the technology journey that we're all going through. Please reach out to either of us if you have any questions or would like to join the group. There's also additional information on SWAN Forum's website. So let's talk about what we're going to cover in this master class. So we're going to talk about demystifying digital twins, really what a digital twin is, the definition of it, architecture overview of the digital twin. And then Chinzi's going to talk about leveraging this architecture really as one of the most important things, which is setting a common language and foundation of understanding across the industry. Then he's going to talk about defining what a complete digital twin is from the technology foundations and from the maturity, how to define how mature your digital twin is and the journey of getting to one that enables a whole new set of decisions. So let's jump into it. What is a digital twin? I've got the definition here that I think is worth reading as it sets the foundation for all of our subgroups and the way we're thinking of digital twins. So a digital twin for water is a dynamic representation of real world systems that is used to describe, diagnose, predict, and optimize through actions enabled by a combination of models and static and dynamic or real-time data. So you see on the bookends of this architecture, really the physical world and the digital twin world, the environment, which is created by these visualizations that enable simulation and decision support tools, and this new set of experiences for all staff within a utility. The ability to do what-if scenarios, have real-time performance dashboards, augmented virtual reality, mobile alerts, and advanced automation. And this collection of tools, if you follow through the bottom, you follow this arrow that's really, this set of technology is enabling better informed decisions that lead to optimized performance and ultimately creating actionable results that improve our communities, our industry, and our utilities. And of course, without, we need to build all technology and this digital twin on a foundation of security and connecting the utilities staff and systems together. So to talk a little more thoroughly about the components inside of this twin, I want to show the first part, usually a lot of the traditional systems that we already have. So the sensing and control column, you'll see where it talks about sensors that we've had for quite a while, pressure, temperature, flow, etc. And actuators, or the final control elements that are typically used, pumps, hydraulic systems, mechanical, etc. And then the category of more advanced or smart monitoring infrastructure, where there's IoT infrastructure that you're hearing about today and throughout this week, as well as AMI and other edge devices. And these are really progressing and working with these traditional data and business sources where data is collected and propagated. So you'll see laboratory information management systems, computerized maintenance management systems, computer aided drafting and BIM infrastructure, as well as automation systems referred to as SCADA or telemetry, etc. And then these foundational elements that provide a lot of additional information for these data systems coming from these other systems, which is its location, the where, or the time that the data is relevant for, so that it can be used and leveraged by the twin. These foundational systems are used as necessary to achieve a new user experience. So that's done through this next phase of really where creating the digital twin becomes super powerful. And that's integrating that data together through ingesting that in dynamic and static ways, and integrating it with data storage and warehousing techniques, as well as cloud and non-warehouse strategies. And it's really powered by this data management foundation. With that, you then bring it into the engine of the digital twin, which is this data-driven models and physics-based models. So the data-driven models are the most advanced technologies that are being leveraged today: machine learning, AI, deep learning, neural networks, etc. But power is combined with some solutions needing and requiring physical models, hydraulic, biological, and more traditional static and dynamic based models. And finally, all of that working together through a new set of interfaces and presenting user experiences that makes this accessible not to just the most experienced digital twin users, but all staff within a utility and the community. That's the power of digital twins. So I want to show just a little bit of how that data might come from these sensors, business systems, automation systems, and get transformed through the integration to new sets of visualizations and create these user experiences. So let's talk about leveraging the digital twin architecture. I'll pass it to my colleague, Chinzi Chu.
Thank you, Mike. So you've taken a look at the architecture. Now let's see how we can use this architecture. So one of the challenges that we see when we look at digital twins in the water industry is a lack of a common language to describe the different characteristics of digital twins, which we can all agree. The way we see it is that digital twin is really a collection of different technology components. And this architecture is a great way to take stock of which technology components you may have in your organization and plan which other technology components you need to really advance the digital twin implementation. So it's a good way to map the ecosystem of a digital twin of your organization. So you can imagine which vendors or partners you're using for each of the technology component, and really to continuously develop these relationships further to advance your digital twin more. Before we get on really further into the completeness and maturity of the digital twin, I'll use this chance to express our views on models and versus digital twins. Are we, using different words to describe the same thing, or are we not? And we think we're not. So just a little quick comparison over here. Conventional models are a really essential part of a digital twin, but a digital twin is more dynamic, it's more connected, and it's more it provides more decision support mechanisms for you. It uses both static and dynamic data, and it's connected to different data streams as well as other systems, so that it can create insights and information that can be used quickly for decision making. And we think that this time to decision making is really the key differentiator that draws this line between the digital twin and the model. Compared to digital twins, a model output really has to be further analyzed and processed before it can be used for any decision making. Next slide, please, Michael. So one of the ways we can further use this architecture I explained earlier is to evaluate how complete a digital twin is for a particular process and the technology used in the digital twin. We recommend starting with the outcome. So in this case, it's maybe an aeration process in a wastewater treatment plant. And let's say we'd like to reduce the energy consumption for that process. So if you take that into account and use the architecture, you can really map out what you have in terms of data and sensors and actuators. What types of models do you need to achieve that? And what type of interfaces for the different groups of people that are involved in this decision process. Lastly, the infrastructure that your system has in terms of automation, it's also key to see how complete your digital twin is. And the idea here is that if you have all the technology components you need in the digital twin to help you reach this particular outcome, then it is complete for this process. Next slide, please. Another way of leveraging this architecture is to look at the maturity of the digital twin. So we look at maturity from a decision point of view, and we break up into 4 maturity levels, as you can see in this pyramid. The bigger base at the bottom indicates that there is more technology at this maturity level today, and fewer as we go up the pyramid. It also indicates that as you progress upwards, your digital twin is more mature and therefore brings more value to decision making. Just to quickly go into it, we have the bottom layer, which is the descriptive level, and that's where the digital twin can tell you and help you with decision making by answering, the question, what is happening now in your system. On the diagnostic level, it would tell you what has happened in the past and why it is happening. And on the predictive level, it can tell you what is likely to happen in the future. And this is also the level where the digital twin is a bit more proactive and is able to forecast in the future and bring you some more insights. And the last level is prescriptive, where the digital twin can forecast in the future and be able to make decisions to avoid, certain events. And this is the level which we are really excited to get into. Next slide, please. So I've covered the completeness and the maturity of the digital twin of a process, but we know that utility has multiple processes. So we see that the digital twin of a utility really consists of many digital twins combined and used for different purposes. And each digital twin can be related to one or more processes, and they can be evaluated on how complete they are and how mature they are in relation to the technology they have and the decisions that they support respectively. Jim from the Lifecycle Group will talk a little bit more about the different types of digital twins. Just a side note, we are working on a white paper in this subgroup called A Path to Efficient, Intuitive Water System Operations. So look out for it towards the end of the year. Thanks, and over to you, Jim and Wagner.
Excellent, thanks, Chenzi. So we're going to now talk about the Lifecycle Subgroup, and a great introduction from Michael and Chenzi talking about the definition of digital twins as well as the architecture that's been developed. So just for reference, we'd love to hear from folks that are attending today as we go through the slides and talk about different types of digital twins across an asset lifecycle. So certainly take the time to reach out to us either through the platform or via emails. This subgroup is co-led by both myself, Jim, as well as Wagner, who will be presenting after me for this digital twin lifecycle subgroup. So what is the lifecycle subgroup objectives? It's one of the newer subgroups within the digital twin work group for SWAN, and we have really 3 primary objectives. The first is to create a diagram demonstrating digital twin types and levels throughout the full asset lifecycle. We'll be talking about that today and presenting what we have developed so far, understanding that is still a work in progress. We'll also be gathering and sharing case studies of digital twins across the asset lifecycle, and then switching gears on the meaning of lifecycle and really talking about how are digital twins maintained and updated, right? What is the lifecycle of a digital twin rather than digital twins across an asset lifecycle? So we've had a lot of subject matter experts across SWAN and across the globe work within this subgroup to identify, when we think of a digital twin, what is that? I think in the past, and maybe some still today, when you think of a digital twin, your mind might immediately jump to operations or optimization, or building on a SCADA system to do modeling of the current system. The Lifecycle Subgroup is really here to describe, identify digital twins across that full asset lifecycle. So we got together, we had a number of virtual exercises, one of the outputs that you see here on the screen currently, looking at what are digital twins and what do they look like across the asset lifecycle. That's evolved a bit, and we've been refining this to the life cycle diagram that I'm going to go through here in the next couple minutes. So building off of the reference architecture that was just described, we start at the core having a digital twin, right? And we know that there's a number of aspects of a digital twin. We're specifically highlighting the analytics piece of that architecture. So we think about machine learning, artificial or collective intelligence, modeling, right? So you have the data models and the physics models kind of within this analytics ring. And that happens throughout the full asset lifecycle, right? So from operations planning, design, construction, and back again with the full circularity of the assets. So we have that there kind of surrounding all of those asset lifecycle areas, because it does truly apply across all of them. Now we can then kind of build out within each of these areas, what does a digital twin actually look like? What is its functional purpose? So if we start with, on the top right, with planning, when we think of a digital twin in the planning phase, it performs activities such as stakeholder engagement and buy-in of what the project or process is. Looking at likelihood and consequence of failure, looking at risk prediction for assets, asset and improvement project impact and prioritization, right? Which project is most important, and what's that impact on our customers and our employees and the overall system. And developing a basis of design, which is really building that connector from the operations piece to the design piece as in that continuous cycle. If we go on down to the design phase in the bottom right, we do things like establishing a data model schema and establishing requirements for new equipment vendors, so that when we design projects, the infrastructure that's coming into our project aligns with our existing digital twin methodology, our libraries, our families, everything that you need to integrate within our existing digital systems, so that it's really, if you think about the life cycle from a digital twin maintenance perspective, you're not having to continuously rebuild your digital twin as you perform improvements projects. That's a seamless connectivity from operations based on that data schema you've developed. Next is 3D context for conflict resolution. So a lot of times we think about various levels of BIM, as will be talked about, but that's one of the primary uses of digital twins in the design phase. Establishing the right level and types of sensors, right? That one of the benefits that Gigi and many others have talked about is looking at digital twins and virtual sensors, right? So what is the right quantity of sensors? What is the right type of sensors to inform your digital twin and allow your digital twin to then provide essentially sensors or outcomes of your process throughout operations. So that's one of the pieces that is really important during the design phase. Automated design and cost optimization, another key component here where we're seeing a lot of digital twin development rapidly, and truly full stakeholder engagement throughout the process. One of the examples Wagner will be showing is showing and demonstrating stakeholder engagement as well. On the construction side of it, so maintenance of operations or MOP during construction, identifying phases of construction operations, identifying what's needed to be offline, when, how it impacts other processes, how it impacts your customers, etc. Conflict resolution, remote expert for progress monitoring, something I see a lot of. Equipment startup and operator training is a very significant purpose of digital twins during the construction phase as we start to move into the operations phase. And cost and construction monitoring, right? How is progress compared to where it should be throughout the planned construction sequencing and phasing within the digital twin, and alignment and understanding differences there. And then finally, operations. So real-time optimization, predictive prescriptive analysis, ongoing operator training, what-if analyses, right? Really utilizing the full capabilities of analytics combined with modeling, combined with your actual operational data to perform very significantly improved and enhanced operator what-if analyses, for example. And sensor maintenance, feedback monitoring, right? Do we see sensor drift? Do we see things occurring that we might need to maintain or improve not only our assets, but our sensors as well, and getting that feedback through a digital twin. So those are just some of the examples. Again, this is a work in progress, and certainly appreciate feedback from anyone on the call and any questions or thoughts on some of these phases. So now I'm going to switch it over to Wagner, who's going to go through a couple slides of his experience.
Oh, thank you, Jim. Oh, great job. Yeah, we are work in progress. I'm learning a lot with this international team. I'd like to share with you idea advancements on digital twin journey. Yeah. Let me first present our company. IDEA is the biggest private group of water and wastewater utilities in Brazil. Recently, our company won the international bid to manage the water utilities in Rio de Janeiro for 30 years. And so we currently have more than 20 million clients in our country. This slide, you can see the Smart Infra program, which is the IDEA water utility vision over the water infrastructure life cycle. This initiative is a strategic digital transformation framework to meet the complex operational, social, and environmental challenges, balancing capital and operation expenditure in order to figure out the best business results. Yeah. We combine BIM methodology, asset management principles, as well as digital twin best practices through the full asset lifecycle. This streamlined business vision was inspired in BS 1192 and ISO 55000, highlighting the water utilities life cycle. The main business phases are represented and aims to encourage collaboration among our specialists at all stages over the life of the asset life cycle through digital analytical models, yeah, as a center to get the better operational and results and benefits. Jim, next slide, please. Yeah, so I'd like to highlight our one of our great challenges as water utility is in Brazil is how to plan and manage sewage construction in congested urban areas. There are many places in Brazil don't have sewage covered, and so it's a big challenge for us. And we are making progress digitalizing the real context and by applying advanced drones and processing technologies. Thus, with the reality model, we are having the understanding of the whole city infrastructure and even the other utilities. Consequently, the design and construction team are being able to propose reliable and alternatives to improve our water and sewage infrastructure, and sometimes even solve some conflict resolutions when we face surprise in the field, as Gina explained before. Yeah, it's a good tool to this graphical resolution is making our decision more accurate, and we are able to share more fast and reliable information with our team. Next slide, please, Jim. This is the summarized diagram applied in IGEA, demonstrating our water, our digital twin applications through our full asset lifecycle. Digital twin is playing a key role in preserving asset lifecycle information flows and thus improving our project delivers and as well as our operations. As asset intensive organizations, we face huge information interdependency across the full asset lifecycle. And so I'd like to share some digital twin applications over the last years, yeah. And so Jim, can you touch? Yeah, this one, yeah, as planning, we are getting to increase our asset knowledge, yeah, raise awareness about the information, the key information for making better, to deliver better plans. Yeah. We are improving our, we are making progress in asset identification verification. We are applying this process to recognize all digitalize the physical assets. In design phase, we are getting to reduce in 30% the errors and omissions. Yeah, it's a great value for us. Yeah, it's we are making as a center, we have the digital twin model, but we are getting to reduce the errors by applying BIM methodologies and tools as well. And analysis, we are getting to develop better hydraulic models, more accurate water balance, as well as our plants. And so we are increasing 50% our the reliable delivering more reliable and accurate master plans. In construction phase is another key value that we are demonstrating with more 2 times faster the commission phase, which we are transferring the complete build project as well as the digital twin model in detail to our operations or to our operators team. And our last phase, our key phase, that we
Sorry,
are.
Wagner.
Yeah. Sure.
I'm sorry, we were just a little bit behind time and we do need to move on to the BIM subgroup, if that's okay.
Oh, okay, perfect. Yeah.
Sorry about
To
that.
conclude, all right.
Go ahead, Wagner, just a last conclusion statement and then Jamie.
Okay, just to conclude, our key issue is to make the physical assets more accurate in terms of information. So we are getting huge progress by applying digital twin principles, and we are getting more information from our assets. Yeah, thank you very much.
Thanks, Wagner. Thank you all for having myself and Chris, the co-chair of the BIM and Asset Management Group, present today. You know, the core purposes group is the fundamental underpinning building blocks to how we can model information to make good insight from it. A lot of the group's work will build on BIM standards that have already been developed, some of them of which have been created by the BIM for Water group, of which I chair. Next slide, please, Chris. Chris?
Yep, you should have subgroup objectives there, Jimmy.
That's brilliant, thanks, mate. So what we're doing within the group is building on existing work that already exists. So this could be around data templates for information exchange and how essentially we can construct information models and systems to make better informed decisions. Next slide, please, Chris. You know, if we think about the life cycle of assets and, you know, what's involved in that, click, please, Chris. We're going to be wanting to build up robust mechanisms for creating information models right from the design, so the planning and design right through to the operation. Have you seen in the other talks, decommissioning and disuse, and another click. So the BIM bit is the middle bit that is gluing this together, and you can see there that it's a real framework that we can build off to build robust asset information models. Next slide, please, Chris. One area that we've not fully explored yet, and again, I'm building off work that's been done within BIM for Water, and I'm referencing standards, is to think about our industry in terms of activities and processes. And one thing that we can do in that space is to build up a digital process block for discrete activities that our industry uses to fulfill its functions. So an example of that could be interstage pumping. And if we built up an agreed process block, which defines which products need to fit within this, we're starting to structure our information sets. So we understand the function and we can make analysis on what value we need from that for the different stakeholders, which Chris is going to explain in further detail next. But it also sets out a framework in which we can gather and model data templates for exchanging information from manufacturers through to owner operators for asset management, etc. Chris, I'd like to hand over to you. Thank you.
Thanks, Jimmy, and hi everyone, great to be here today. And I'm just going to pick up on this digital process block and go through a bit of a template around how to use it and what it looks like. And it's actually building off some work that was completed with Anglian Water here in the UK, who are actually on next to talk about outcomes, which is a nice fit, as you can see how this comes together. So as Jimmy mentioned, a digital process block, it could be a schematic, it could be a simplified view of what you see here, it could be a general arrangement drawing, it doesn't matter. It's about the ability to chunk down into component parts what a digital twin is, because a lot of the frustrations or challenges around digital twin is setting the boundaries of it and where to start. So a process block is a nice entry point and a way of setting those boundaries to then say, okay, what are the standards and reusable methodologies that we want to apply to that component or digital process block. So what you see obviously is that on the right. And on the left, again, a familiar component I'm sure some of you have seen where you've got the sensors and assets, the data acquisition component, how that integrates through into analytics and visualization, and of course, for what purpose. And that's the informed decision making, which is what we're all about. The digital twin has to add value. We talked about that in the definition about how it does that. So it's about bringing those two pieces together And the objectives, as Jamie mentioned around the subgroup, is to create a reusable library of available standards and processes to give that digital twin value. And so I want to show this as a template. You can take this away and use it yourself. You may be using it already, and there's an ask in this, as there has been with the other subgroups, to join and contribute to what our subgroup is trying to achieve. And I'll just show that here. So what we're doing is taking that same digital process block. We are identifying which assets are critical, because what we have realized through our digital twin journey is just because you have the technology doesn't mean you need to apply it on every asset. And so it's about understanding from that decision or outcome you're trying to meet, which assets are critical to obtaining that. So you can see the little start here. We want to start with the end in mind. What is the outcome we want to achieve? And from there, we've picked a simple process around, obviously with interstage pumping, and a simple decision or insight around asset reliability. Now that ask can be quite simple. The route to get there can be as complex when we think about, we touched earlier around descriptive analysis, predictive, and so on, and even prescriptive in terms of deriving an action of a defined response. And so what you can see as a template is, and linking to BIM and asset management is the area of, we want to achieve the decision and insight. Now, I know it's a little bit confused, but jump straight to the bottom. What standards can you use that help inform the data attributes by component type that's in that digital process block, so a pump and so on and so forth? What are those static and dynamic attributes we referenced that you need to be able to make that decision and insight? And then working our way through what's the analytics and what's the visualizations. So from our group, what we want to make is this library that you can basically, driven by this process block, to then say, okay, what can I go and avail of as a library of standards and analytics, or standards, data attributes, analytics, based on this outcome or this insight that I want to be able to make. So that's a really important component, is we're trying to take two simple things and make a reusable library, so as people can have a good place to start, and enough in many ways save any abortive work or rework in terms of by learning industry best practice for these component parts in that digital library. And so, as I mentioned, I did say there would be an ask in this. So where do we go from here? This is this reusable library. So you can imagine we've got interstage pumping. You can have the key processes, again, keeping criticality in mind. Which key processes across water infrastructure and non-infrastructure, water, wastewater, because obviously keeping on the water treatment process. Which component parts or process blocks would we want to prioritize as we build this reusable library out? And so the ask, I guess, is twofold. One is to feed in the priorities of which process areas we would like to see go first in our objectives, and then also to, by way of technical contribution, to what makes up those standards. So as Jamie mentioned with BIM for water and so on, we've got lots of vehicles to inform what those standards are in the context of a digital twin, and that ask is to help contribute towards that as part of our subgroup objectives. So hopefully that was useful. You see there's a template there, as I mentioned, and how we bring those two components of the digital framework from data acquisition to decision and map it against a simple process block, which is easily identifiable and reusable, to then grow that out as a standard accessible library that's available to anyone wanting to embark on a digital twin journey. From there, then I would say come and join us, and there's some key contact details to be part of this or any other of the digital twin subgroups, which leads me nicely on to handing over to Alex and Kevin, who are going to talk about outcomes.
Thanks, Chris.
Pedro can go ahead and kindly share. Thank you.
Okay.
apologies, Pedro. I didn't mention
No
you in that
worries.
handover, so I stand corrected.
I hope you are seeing now my screen. Can you confirm you are seeing my screen, please?
Yes, great. Thank you,
Okay.
Pedro. Thank you.
I'm very sorry for this late introduction. My name is Pedro Vieira, and I'll be joined by Kevin Reeves and Alex Bailey, both from England Water that are substituting Andrew Smith that shouldn't join us in this group presentation. So the main objectives of this part of the outcomes and applications are actually trying to explain to answer 3 questions: why one should implement digital twin solutions, how one could start implementation, and what major themes should be managed in order to implement a digital twin solution in a water utility. So I'll kick in now with Alex Bailey that will explain some experiences from England Water, please.
Thanks, Pedro. Delighted to be here, everyone. It's Alex Bailey from Anglian Water. We're just going to take you through a couple of slides of kind of our experiences of digital twins thus far, and hopefully give some concrete examples of the outcomes we're looking for and the applications we're using to get there. Just briefly want to explain the definition we use in Anglian Water. It's based on the SWAN one that was shared earlier, but we define it as an integrated, accurate digital representation of physical assets, systems and treatment processes that we use to unlock value by enabling improved insights that support better decisions, leading to better outcomes in the physical world. Importantly, one thing I feel very strongly about is something that distinguishes a digital twin from any other type of digital model, as Chengzi was explaining earlier, is its connection back to its physical twin. So in other words, that there's some type of relationship and association between the physical and the digital. So at Anglian Water, we use the resources from SWAN very heavily in our work, and the diagram that you can see here, hopefully you recognise as kind of our version of the digital twin diagram that was shared earlier. And I hope it demonstrates that we have many of the component parts of a digital twin. We're quite advanced in our sensoring capability. We've got data centres, even analytical and visualization platforms such as our near real-time model and other tools there. But like others on the call, we're still grappling with questions around outcome and benefit and exactly how we want to use the tools available to us. And it's that I hope to share a couple more points on over the next few minutes. Thanks, Pedro. So I'd like to use the SWAN digital twin components of describe, diagnose, predict and prescribe to break down some of the real examples of the outcomes we're pursuing and the applications we're using to help get us there. So firstly, we're using near real-time modelling and software provided from Innovise to do that, to visualise real-time system activity and performance. And by being able to view live information about pressures, flows, demand, asset data and set points, we can improve our decision making, reduce rework for field teams, improve safety and minimise any impact on our customers when issues occur. And that last one will be a common theme throughout this. We'll touch on this again later in our presentation, but of course, doing that relies not only on excellent digital tools, but good data to feed them and good people to take action as a result. Moving on to diagnosis, probably one of our weaker areas at Anglian Water, I don't mind admitting. We've got most of the data we need, but investigating issues is still a fairly manual process for us. We have developed some notable internal tools such as transient detection metrics and calm network assessments to support us in that and to help us use our resources as efficiently as possible and solve the root cause of the issue right first time. Of course, doing so saves us time, cost, and again, limits potential impacts to our customers. We've got some really useful predictive tools as well. One that was built in conjunction with Cranfield University called Whisper, which predicts our overall numbers of bursts based on a whole myriad of different factors, as well as tools such as Demand Watch, which forecasts demand within the near real-time model accurately 24, 48, or even 72 hours ahead. Both of these tools help us to see issues coming and to respond to them earlier, either enabling us to prevent the issue entirely or mitigate customer impacts where the issue does unfortunately occur. For prescribing, what we do here, for prescribing actions and operations, we're currently using BalanceNet, which is another Innovyze tool which utilises near real-time modelling to produce optimum pump schedules, driving outcomes around energy efficiency and cost reduction. We also have a number of condition-based monitoring technologies in the business that predict asset failure and provide diagnosis and prescriptive resolutions to those. Both of these things mean we can intervene prior to something occurring, prior to a failure, saving money, being safer, and again, that golden theme, preventing impacts to our customers. We're still on a journey with all of this, much like everybody else on the call. And whilst the applications we use might shift as we learn and grow, the outcomes that I've described and that are shown on the screen are likely to remain fairly consistent. If I could have the next slide, please, Pedro. Perfect, thank you. This slide covers a few of those outcomes in a bit more detail. So I told you that we use the SWAN layers heavily in what we do. We've also added a couple of layers on the top there around decision making and business goals. And we use these to align our investments, projects and efforts to real business needs. I'm not going to read out all of these, but hopefully you can see that there's a vast range of benefits and smarter decisions we can start to make with the applications and tools available to us that will in turn improve the support the business in achieving its aims. Again, a really fundamental point, I think it's worth pointing out that getting from level 5, where you've got your data fusion and analysis, to level 7, where you're delivering business goals, requires people and process change, both of which are absolutely fundamental to releasing benefits and delivering desired outcomes. The few diagrams on the right there, you can see, apologies, they're probably very small, but there are a couple of examples of the outputs from the applications on the previous slide. So examples of the near real-time model, of the demand forecasting that we can do, and at the top there, a logic map for the pump control that I described. But without further ado, I'll hand you over to my colleague Kevin to explain a bit more.
Yeah, thanks very much, Alex, and good afternoon, everyone. Hope you're enjoying today's session. So I wanted to give a slightly different view now from the Strategic Pipeline Alliance, or SPA for short, which is a capital delivery programme within Anglian Water, delivering a kind of a new pipeline that's going to extend from the north of the region all the way down to the south. Now, what's really interesting about SPA is it gives the opportunity really to think about how the digital twin in the capital delivery phase can support the outcomes of Anglian Water as a business. So one of the first things that we decided to do was focus on the regulated outcomes of Anglian Water as a business. So Ofwat, the regulator, sets what are called outcome delivery incentives, and there's financial benefits for Anglian Water to meet those ODIs. So we kind of started there, and then we've almost sort of worked down really, following a globally proven enterprise architecture framework called TOGAF, that we have also then aligned to the SWAN layers, to really start with those business outcomes and the strategic objectives of Anglian Water, and start to understand, well, what are the capabilities that we need to think about developing in SPA that can help support those outcomes for Anglian Water. At the same time, we've had to go through that same process for SPA as an alliance. As part of the business case development, we've had to demonstrate the value to SPA in capital delivery, but also showing to Anglian Water, well, look guys, if we invest here, we're going to open the door to some of the future capability that you want to drive on your roadmap. All the way down that enterprise architecture model, then we're able to track how people interact with the digital twin, and importantly, what type of information are they going to need. So, interesting listening to Jamie and Chris earlier on, mentioning the work within BIM for Water. Well, the models that are being created there are effectively forming the information foundation of the digital twin within SPA. Also leveraging a lot of the good asset information models that Anglian Water have been developing, over a number of years. Next slide, please, Pedro. So these will give you a very brief overview of some of the applications that we're starting to use and develop as part of SPA to help meet those outcomes. So as you would imagine, there's a big focus on net zero and how we can help Anglian Water achieve its goals. So there's a heavy use of geospatial technologies integrated with BIM models to help us really start to understand the impacts of climate change. So, as a capital delivery project, it's really useful to understand the impacts of weather, as an example. So that shows there some of the, it's a bit of a small picture, but what that shows is some of the flood data that we're able to integrate from the Environment Agency that gives the projects the insight they need to understand the potential impacts of flooding within that project. So it helps them describe and diagnose the root causes of some of those challenges and mitigate those risks. So it's, one example of the type of application that links directly to an outcome of both SPA, but also Anglian Water. Alex mentioned the near real-time modelling, and what's fascinating about that solution is it's essential, actually. We can't operate SPA as a scaled asset without that near real-time model. We need that to be able to predict different scenarios in a safe simulated environment to understand how pressures are going to react within existing systems. Because SPA is effectively joining up existing water networks, and we really need to be careful about the pressure and the flow management as part of this project. So using that near real-time modelling to give us that predictive capability and then prescribe the different operational conditions that would optimise the network is absolutely key. And the last one that I wanted to pick up really was, the sort of the evolution, I suppose, of some of the leading edge technologies. So we've been trialing reality capture, and this has been fundamental actually to helping SPA understand how we come back from the world of lockdown and back into this kind of hybrid remote working scenario. So, we've been able to very quickly, in fact, within a day, create a realistic model of the office and link effectively all of the induction material, the training material that we would normally give to people. Within 2-3 days, we've got a lifelike model where we can effectively remotely onboard people into the SPA program and induct them virtually. So it's just another example of how these types of digital twin technologies and approaches are helping SPA and Anglian Water achieve their outcomes. So that's it for me. I'll hand back to Pedro now just to cover off some conclusions from today.
Thank you very much, Kevin. And just to finish this presentation, I would like to talk about some of our conclusions about the way people are important in all this process. So we gathered some bunch of volunteers, and also we asked some questions to some utilities. And the idea was to gather the information that they could give us about the main problems that they face in the adoption of technology and digital twin. So what is common is that people should be core of digital twin journey, and also when introducing digital twin interfaces, that they should be made according to their people experience and expectations. And with the aging workforce that is retiring and the new tech-savvy generation that is attracted by digital solutions, digital twin implementation can be a source of empowerment to new workers and also to the actual workers that are trying to shift to new ways of working, even though they have strong knowledge of the network function. Fundamental shifts are in the way of how utilities operate, and that will also change the way utilities operate in the next few years, and more efficiency can be achieved with the use of digital twins. So digital twin is a way to achieve more efficiency within our utilities. Engagement, cultural change leading to a future business operating model are also very important themes that should be treated very seriously when we take care of us, when we ask ourselves what type of digital twin we want to incorporate. I shall give you just now a brief introduction what was done in our report in Portugal. So what we did was to integrate all the sensors and all the data and information in one single water integrated system. that gathers information for all types of sources. And then we gathered all the models that we use in the company, and we have followed the SWAN approach for making predictions and making prescriptions, and also analyzing data within the company. All of this gave us higher performance, and people's engagement rise also. And in the end of the day, what we measure are the consequences of implementing a BIM, a digital twin solution within our company, changing what people do and which process they use to do their day-to-day work. So here are some numbers that we gathered in the after the implementation of the new technologies. We are still implementing new technologies that arise from the implementation of our digital twin. The idea is to keep it ongoing and implement the new technologies that are focused on and are directed with the main board directions. So, in conclusion, digital twin decisions should align with organization purpose, values, and strategic outcomes. We should start with the business strategic objectives and, importantly, related outcomes. Along with the technological change, a cultural change is critical. So, what our group of volunteers found is that a digital twin can be very different from case to case, and as it is a cultural thing to implement in each one of our utilities, it should be adopted in which utility, taking also good care of people expectations and of also the knowledge that the utility possesses. So digital twin should be viewed as enablers to business change, and that change is mainly direct to people and processes, and cultural adoption needs to be considered only on defining how people will interact with digital twins also. So what we concluded was also that one size does not fit it all, especially with larger utilities that have a lot of systems and a lot of legacy systems that have to have different types of approaches and other frameworks. You can use proven frameworks, and we don't need to reinvent the wheel. And there are three key elements very important to the implementation of the digital twin, that is technology and data, processes and people, as I talked before in the other slides. I'll just wrap up with some points to reflect on, like, is digital twin one thing, or there are several components within another? What comes are common to all and which are unique? So this is a thing that we have to dig on and be more specific on. People must be at the very heart of digital transformation, that it can be very harsh and hard to do, and that implies the management compromised in order to take this forward. And benefits and outcomes are really hard to quantify in the early stages. As I told you before, in Agos report, in our particular case, it was very important to have specific KPIs to follow, and to some extent there is a leap of faith required. So this is just a provocative phrase. Now, shall finish now, and I'll get back.
Yes, thank you, Pedro. Yes,
you are very welcome.
You can stop sharing your screen, and Travis,
okay,
you can take us away. Thank you so much.
Yeah, absolutely. Wow. When somebody says masterclass, I want everybody to take note. That's how it's done. There is a lot of good information there. And I feel like after this morning, well, at least this morning here in the States, I'm about halfway to my digital engineering PhD. So there just a lot of good data there. Michael, Chengzi, Alex, Pedro, Wagner, Jim, Chris, Jamie, Kevin, all of you, thank you very much for being thought leaders in this market, and for presenting here at our masterclass.